press pause and answer the question.
All right, so now we're back in the kind of construction mode, and we're going to construct a circular fountain, something like this. And it's a perfect circle, and the radius of the finished fountain will be 9 feet. So we've got a portion of it done. We've got this portion from Y to Z, and we have the center point O. And it's given that this portion of our fountain, the angle of YOZ, is pi over 3 radians. And it's asking, what's the area of the fountain that's been completed to the nearest square foot? And the answer is this one, 14 pi square feet. Now, you may be asking yourself, why are we even working with radians? Degrees seems to be pretty comfortable. I already understand degrees. And in a way, it's a little bit like Fahrenheit and Celsius. We're kind of more comfortable with Fahrenheit, but we recognize that Celsius may be a bit more rational and have a little bit more reason behind it. And we know that scientists work in Celsius, and we know that scientists work in meters, although we're more comfortable with feet. And really, the reason we work with degrees is pretty arbitrary. It has to do, well, let's talk about our Babylonian uncles, maybe like 3,000-ish years ago in what's present-day Iraq and Syria. And they had a base 60 counting system. Now, what's our counting system? Our counting system is base 10. So once we get through these 9 symbols, we then go to this, 10. And then once we get through these 9 symbols, we go to 20 and so forth. It keeps working 10 and then 100 and then 1,000. And so we have a base 10. Why is it base 10? Why not base 12, which kind of makes more sense because 12 is a little bit easier to cut up into different pieces. We do base 10 because our ancestors, their job was to make sure that they were shepherds, right? So they wanted to make sure that we're still as many sheep now as there were an hour ago. So they had to count the sheep, and they counted on their fingers, and they had 10 fingers. So every time they got to 10, they'd make a little tick mark in the ground with a stick, and that represented 10. And then they'd do 10 again. They'd count on their fingers, and then they'd make another tick mark, and that was 20, and so forth. Now, some cultures use a base 20. And why is base 20? Because those cultures use their toes also. So it just so happens that the base 10 won out, but we easily could have had different symbols for everything from 1 to 20, which now 1 to 20, and then it would start again at 20. Some things we use, though, are still base 12, something like the months in a year. We have 12 months in a year, and then we repeat it, right? And the number of hours in a clock. We have 12 hours in a clock, and then we repeat it. Other things that we do every day are base 8. So, in construction, the units we usually use are 1/8 of an inch. Our units for measuring things are often 8 inches, like the height of a concrete block, or 8 feet long, like the length of a piece of plywood. But our Babylonian ancestors, they were really into base 60. I'm not really sure why, but they thought they had 60 different symbols. So the way we have 10 different symbols for our numbers, and then we just kind of keep adding numbers from there, they had 60 different symbols. And that's why we have 60 seconds in a minute, and that's why we have 60 minutes in an hour. And they had their equilateral triangles divided up into 60 sections, 60 equal pizza slices, right? So if we look at a circle, we can say that there's 360 pizza slices in the whole circle because there are 6 equilateral triangles that we can place around the circle. And each one has 60 sections because Babylonians, everything they just divided into 60s. So we have 6 times 60 is 360. That's most likely why we still use 360 degrees. But it's pretty arbitrary, and it's not totally intuitive. So why use radians? Well, in radians, if we have, say, 1 radian, it's like this big, right? That's our angle. And what that means is it means that the length of our radius here is equal to the length of this segment of the circle here. That's why radians. So it's a more rational kind of approach, and it's useful in some areas of science. It's worth the confusion of going from degrees to radians because it makes more sense. So 2 radians is this much, and if we keep going around, we see we have a little bit more than 6 radians. How much more? Well, basically, we have 2 pi. 2 times pi is the total angle. So 360 degrees is 2 pi, and you probably knew that. So what we have to do anytime we're converting radians to degrees and back, it's best, I think, to think of it as a proportion. So your number of degrees to 360 degrees equals your number of radians to 2 pi radians. That's our ratio. So in the case of ours, we know we have pi over 3 radians. That's our angle. And you can just look at that and know that's 1/6 of the whole way around. But even if you weren't able to kind of look at that and see that pi over 3 is 1/6 of 2 pi, we can just do it as a ratio. So we can say 360 degrees over 2 pi times pi over 3 is equal to 360 over 6, which is equal to 60 degrees. 60 degrees. So 1/6 of the fountain's been completed. So the area of the entire fountain, once completed, will be area equals pi r squared. Area equals pi r squared. And in this case, it's given that our radius is 9. So area equals pi times 9 squared, which is equal to 81 pi. The area of the completed section then is 1/6 of that. So it's 81 pi divided by 6, which is 13.5 pi. And that's our answer.